Welcome to Lab 2. I'm Marcus. In Lab 2, we're focusing on the physics principles of Newton's second law, force equals mass times acceleration, which further derived gives you V final equals V initial plus the net force divided by the mass times the change in time. The two forces we're going to focus on in this lab is the gravitational force on the object and also the drag force. In my experiment, I dropped a lacrosse ball from a height of 1.8 meters using the person as a reference, and the ball weighing approximately 0.15 kilograms. To model this, the first model is going to be gravitational force only, neglecting any drag force acting on the object. To do this, the weight force is going to equal the ball's mass times the gravitational constant 9.8 in the negative y direction. Since we're only using gravitational force, F net is only going to be equal to the weight force. Since F naught is not zero, the ball's velocity is constantly going to be increasing. Thus, the line will not be straight at the position. We see this in the model once it's ran. We have a sloped curve because it's showing positive velocity and acceleration in the object's movement downwards. The next code is going to be with gravitational and drag force present. So we keep the same weight force as we did in the last code, but now we're going to add some turbulent drag. Turbulent drag is close to the same as the speed squared. So to get this, we're going to take the magnitude of the velocity and square it. So therefore, in our F net, we've got the weight force going in the negative y direction plus drag force going in the positive y direction, the opposite direction of motion. Therefore, our ball velocity has a changing net force since Fd, which is our drag force, is not going to be constant. Therefore, we're going to keep increasing the velocity until the drag force and the gravitational force are equal and we get an F net equal to 0. Then the line will straighten out. This is also shown in the model once it's ran. Here the line begins to curve early on, but as the drag force increases, it begins to match the gravitational force and they become equal. This causes the velocity to become constant and give us a straight position line. After collecting experimental data and model data, I have plotted them here on this graph. The blue dotted line is the experimental data, with the red being the model without drag and the orange being the model with drag. As you can see in the first 0.3 seconds, the experimental really doesn't line up with either of these. That could be to tracker plotting error on my part. But really what we're going to focus on is towards the end right here. So the experimental model at about 0.35 seconds starts to match up with the model with drag, because the red model line is going to keep accelerating because I have a constant curve, but the experiment is encountering drag force just like the model with drag, and therefore the line is going to start straightening out as the velocity becomes constant. So after collecting this data, we have a couple review questions. First off, we're going to examine what velocity versus time has to do with terminal velocity. So terminal velocity is going to happen when the object's drag force is equal to the gravitational force pulling it down. That means that terminal velocity is when the net force is 0 and the velocity is no longer changing. The next question is, what if the object was thrown down and not drop? This is going to have the same terminal velocity because in the beginning, once it's thrown down, the drag force is going to be much higher than the gravitational force. Therefore, velocity is going to be slowed down. Velocity is going to keep decreasing until the drag force and the gravitational force are equal, once again giving us our terminal velocity. To summarize Lab 2, we focused at gravitational force and turbulent drag and what it has to do with terminal velocity. From the models, we've shown that speeds keep increasing until the gravitational force and turbulent drag become equal, and then the velocity starts to straighten out as a line because it becomes a constant. And that is when we reach our terminal velocity. Thank you for watching Lab 2. Drop position. Now, the drag opposing force to gravity's objects will increase or decrease speed until the forces are equal. So if it's thrown down, the drag force is going to be